Okay, so let's go to the quiz and let's do it. I know some of you had trouble getting in, but hopefully a lot of you, sounds like some of you got in, which is good. So it wasn't like the whole thing was a disaster, but it was for a few of you. I want to remind you as I do that, that if your computer did not work at all, then another option is to go to the college, contact the college, and I have to verify for them that you're my student, that you need it. And they can give you a Chromebook computer. Okay, and those should work because they've hopefully tested them. Okay, so that's a plan B if your computer's not working. But the other thing is, and I mentioned on this sheet, there's a live chat where you can get help. Okay, and you can call them also, but there's lots of ways of figuring it out. And this, again, this is in the module, the first module that you can read this through. I'm not going to read it all, but because I'll let you do that if you had any trouble. Okay, so let's talk about the quiz. Okay, so the first question is, you're offered a job selling life insurance to people who click on an interest tab, where those who click get paid $1 by you, by the way, for clicking, and have the conversation with you. 5% of those who click buy the standard version of the life insurance, and you get paid 10 bucks for each of these. An additional 2% of those who click buy the premium version of the life insurance, and you get paid $30 for each of these. You get paid nothing for the rest. Okay, so again, 5%, you get paid 10, 2%, just you get paid 30, and the rest, nothing. And it costs $1. Costs you $1. Okay, and you have to do a probability distribution table. We have to use the calculator to find the expected value and standard deviation, and then you have to interpret the expected value. And note you are to interpret the number, not just the sign of the number. So let's start out. Let me get there. Well, let me answer. I think I'm previewing it, so I'm not sure if I can. I think I have to re-log in. It timed me out. So there's a way to do this. So preview. And there it is. Okay, so first let's make the table. And you could make it rows or columns. That doesn't matter as long as you know what you're doing. And I'm going to use rows. And we have, who remembers what you labeled the very first row?
X.
Yep, that's X. And what do you label the second row?
PX.
Okay, and now we're going to look at the different X's. Okay, so if you're able to, you know, sell that standard insurance, what's your profit? And again, you may need to read the question again. So if you sold the standard insurance, that was these guys. What's your profit? How much money are you profiting? Y'all jumping in at once. This shouldn't be that hard.
$9.
Yeah, it's $9 because you get 10, but you pay $1, right? Just when they clicked, you had to give them $1. So our profit is $9, and that's the first X. What other X's can happen? Well, you can get the deluxe version, and that's a $30, but you had to pay $1, so it's 29 left. Okay, is there anything else that could happen? Are there any other values of X, or is that it?
Not getting anything at all.
Would you do -1?
Yeah, and in particular, it's not really not getting anything. It's actually losing $1. -1. Does that make sense? Because you got to pay $1 for everyone who comes in. So if they didn't buy, then you just lost $1. So you get a -1. And then we said there was a 5% chance of getting the standard version, and that is 0.05. There's a 2% chance of getting the deluxe version, so that's 0.02. How do I figure out the percent chance of losing $1? That's a little math, huh?
100% minus 7%?
Yeah, so 100% minus 7%, and that's 93% or 0.93. Any questions on that? Okay, so that was part A. Part B, we need to use the technology, and you'll see in here, which one do we choose?
Binomial, which one? Expected value?
Yeah, this one's the expected value and standard deviation because that's what we want. We want the expected value. So we can go to expected value. And now we just put in the numbers. The numbers were 10, 30, and -1. And the probabilities were 0.05, 0.02, and 0.93.
I thought it was 9, 29, and -1.
Oh, I'm sorry, 9. Whoops. Yep. Thanks. And then 0.05, 0.02, and 0.93. And then we just hit calculate. And there we go. Our expected value is 0.1. Our standard deviation is 4.66. Okay, then let's write that down. Expected value was 0.1. Now I'm going to use 2 decimals. Why do I want to use 2 decimals? There's a reason. Why do I want to write 0.10 instead of 0.1? Yeah, this is money. And money should never be done in tenths. It should be done in hundredths or whole dollars. And clearly whole dollars is silly here. So now we're talking about 0.10 because it's 10 cents. Our standard deviation was 4.668. In fact, I'm going to put a $sign there to remind us that this is actually money we're talking about. And then we're asked to interpret it. Remember, I told you there were some words you had to have. Okay, so what we can say is that if many people clicked on the offer, then it is likely that the average profit per person will be close to 10 cents, like that. Any questions at all on this question? So unlike chapter 3, once you can really do one of these, then they're all the same. I mean, the words are different, but they're all kind of similar. So get good at this by next Thursday so that you can do well on the test for that problem. Chapter 3, they're all a bit different. So that takes a lot of different ones to practice. Here you can actually just study one example and get good at it. Okay, notice the high standard deviation. So again, you better be there a while before it happens. Any questions? Okay, let's look at question 2. Okay, so question 2 is a little depressing, but you know, it's reality nowadays. Okay, suppose that 17% of all people over 85 years old who get COVID-19 die from it. Okay, and this, by the way, is something that I did look up, and there were conflicting numbers, but they were typically between 15 and 20%. So I used one of them that I found that said 17%. Sweet Living Retirement Community currently has 35 residents over 85 years old who have COVID-19. Find the probability that exactly 6 of them will die of COVID-19. So exactly 6. So I'm just gonna write down in my little notes, we have 17%. What's 17%? What letter is that? Or what is that?
X,
It's not X, good try though.
PX,
Yeah, that's P. That's P. Not PX, just P. Probability of it happening. So P is 0.17. You always have to make it a decimal. What's N?
85, 35,
35, yeah. 85 is their age, which has nothing to do with how many people there are. 35 is the number of people. In fact, you never use the number 85. Okay, so now let's do part A. Exactly 6 of them will die. So now I'm going to go here. And which one do I need now? Yes, this is a binomial. By the way, did anyone get in successfully do this?
I did.
Okay, did the technology work this part?
Yeah.
You were able to get the calculator work? Okay, because this is my first time ever doing this. We're embedding it into Canvas. So I'm glad it worked. Good. So that sounded like a lot cleaner than Proctorio. So all I could tell you is I programmed this and I had nothing to do with Proctorio. So Proctorio is a lot deeper actually. Okay, now if we want to find out the probability exactly 6, what's the lower bound?
6,
Yeah, it's just 6. Anything under 6 is not exactly 6. What's the upper bound?
6,
6 again, because anything over 6 is not exactly 6. Our trials, that was our 35. And P was 0.17. Okay, and I hit calculate, and you get 0.1763. Any questions on that? Okay, so now I go down, and part A was 0.1763. By the way, if you're not sure if it's right, what should you do if it's a quiz or a test, for example? What
Well,
should you do next Thursday?
put something in, don't just leave it blank.
Yeah, but no, but you got this and you're not sure if you actually did it right or not. You got the number 0.1763. It might be wrong. You're not sure. What should you do? This is important. Any thoughts? You should write a little explanation of what you did and how you got this number. And that way, if it's not right, I can still give you some credit, a lot of credit, especially if you did most of it right. So you can say, I put in 35 for the number of trials, 6 for both the lower and upper bound, and 0.17 for the probability. And what that does is that, let's suppose you made a mistake. Let's suppose you use 85 instead of 35 because, I don't know, you read that age and thought that was the trials. Then I could say, well, you got the lower and upper bound right. You got the probability right. Look at that. You got like 3/4 of the problem. And I'm going to give you 75 or 80% of the points, even though your answer's wrong. But if all you put was a number that is not 0.1763, then I can't give you any points. Sometimes I'll give 1 point as a mercy point, but I can't give you anything. So
What if-
especially
what if-
next week on the high stakes, you
What if I
definitely
just put
want.
like,
What's
sorry.
that?
What if I just put like range 6 and 6 and
That's fine. That's fine as long as you're explaining yourself.
Okay, okay.
Yeah, I'm not saying you have to have this exact wording,
Okay.
but if all you have is a number, I can't find points for you. Does that make sense? If you have the number, but the number's not right, I can't give you points because there's nothing right. Do you see that? If you put range 6 to 6, that's good. That tells me you know what you're doing. You see what I mean? Okay, so there's lots of ways of wording the explanation, but give me the story. Okay, and then part B. Let's read it. So part B was, where are we? It's over here. More than 6. Oh, sorry, I shouldn't say but. That's a typo. More than 6 of them will die of the COVID-19. Okay, so more than 6. What changes for the more than 6? I'll even go to the calculator now. Of those 4 numbers, what's different?
Up.
What's that?
That one.
Okay, the upper is different. It shouldn't be 6 anymore. What should it be? So if it's more than 6, what's the highest number it could be? 7. 7's more than 6, but it could be 8, and 8's more than 6 also.
We're watching you.
My statistics class.
Okay, so any thoughts?
Sounds great, huh?
The highest number, by the way, we can hear you. It does sound great. So the highest number it could be if it's more than 6 is 35. Right? Everybody could die. I mean, it would suck, but you know, that's the highest possible number. What about the low? Does that change? Is 6 a number more than 6?
Well,
6 is not more than 6. What's the lowest number that's more than 6?
7.
7. Right? And these are deaths. You can't have 6.3 or anything. Either die or don't die. Okay. Notice number of trials is not changing and p is not changing. So I hit calculate. And you get 0.38. So let's do that. And I'm going to write is I put in. I'll even copy and paste because I can do that. Copy and paste all of this and then fix if I need to. I put in 35 for the number of trials. I put in 7 for the lower and 35 for the upper bound and 0.17 for the probability P. Any questions at all on part B? Okay, let's go to C. C says at least 4, but fewer than 8. So at least 4, fewer than 8. So what changes now?
The low value and the upper value.
Exactly. So what's the new low?
4.
4. At least 4. 4 is at least 4. That's something to remember. Okay. Fewer than 8. What's the upper?
8.
Is 8 fewer than 8?
No, 7.
Is 7. Does that make sense? Yeah. So always a good idea to kind of think this a few times because these are typical mistakes people make is they misread these words like fewer than. Okay, and then we trials and P, same, and you get 0.6337. And let's copy and paste this just so I can show my work. So I put in 35 for the number of trials. Now I put in, let's look at it. It was 4 and 7. 4 for the lower and 7 for the upper. Okay, and 0.17 for the probability P. And there it is, that's the whole quiz. Any questions at all on this quiz? I know for some of you, the hardest part of the quiz was Proctorio, and sorry about that. We're in weird times right now. I wish we were in class and I could just hand you a piece of paper and you write on it. That's what I do normally, but I can't do that. Okay, any questions at all about this? Okay, so now I can talk about what we're doing today.
Don't forget, oh, are we recording? Yeah, good.
Yeah, we're recording. We've been recording since Anna reminded me to record. Thank you, Anna. Because that is something I forget sometimes. And always remind me if I forget. Yeah, so I did that a while ago. So that'll be recording. Okay, so what we're doing, by the way, is we did our quiz. We went over it. And hopefully all of you will be able to get into Proctorio by the end. Okay, by next week, I mean, is what I meant. And but don't wait until next Thursday to start trying. You want to make sure if you got in this time, you're good. Yeah, I can't imagine it being much different next week because I won't do anything different. Next, I want to remind you about the project. Okay, so the project, when is the project due?
Tuesday.
Yep, project is due Tuesday. Okay. Okay, it's due Tuesday. And Sunday will be the last chance for you to send me your draft for me to look at it and give you suggestions. So 48 hours is my deadline on that. And I read them on a first come, first serve basis. So if I get a whole bunch at Sunday at the last moment, and you were the last of the last to happen, then it's gonna be a while before I get back to you because it's a lot of pages for me to read. So the earlier you send it to me, the faster I'll be able to get it back to you in terms of suggestions for improvement. And I want you to all do well, but I can't help you unless you tell me what you're doing. And then you can email me your project. I can email you back with a bunch of suggestions. I just want to mention something. A few things to look at. If we go to the Project One guidelines here, there's a link where it says you can see examples of feedback that was given to students on their draft of Project One. Okay, and if you click on that, what I did is I literally copied and pasted some example feedbacks that I gave to students in the past. Just some, I think 3 of them or something, so that you can avoid making those mistakes. So I recommend you reading. I'm not going to read through that now, but you can read through it. And that will help you see where people make mistakes. Okay. And I didn't want to make it overwhelming. I could have made this 100 pages, but that would kill y'all, I think. You'll freak out. So I made it a few pages. Okay, so that's just a note, is that you should do that timeline. The hope is you've already decided on your project. You've already posted it on your the project forum, so that I told you it worked. You've already decided who to ask based on stratified sampling or cluster sampling. And almost all of you are going to ask online because we're in weird times right now. And again, if you each ask 11 people, that's perfect because that's more than 30. Okay, so if one person asks 16, the other person asks 15, and there's 2 of you, that's fine too. Okay, it has to be more than 30 though. So that's just a note about the project. Not only can you post your idea for the project on the Project One discussion, there's a Project One discussion board. Looks like there's a new one already. Okay, so not only can you post your idea, but you can also post any questions you have. So if you're working on the project and you've already done You've already sent the idea, I liked it, and you're stuck on one thing, post, and then I'll answer. Okay, I'm on pretty often. Don't expect it to be 10 seconds I'll answer, because I might be somewhere else. Might be taking a walk. I do that once in a while. But definitely within not too many hours, unless it's after 9 p.m., then it'll be like 5 in the morning for me. That's just my style. Okay, so that's just a note. Use that to ask questions.
My group noticed that a couple of the groups on the discussion board were trying, including ours, trying to do comparative studies instead of what we were actually assigned to do. And
Yep.
we were hoping to, or at least we talked about or considered, parlaying project 1 into project 2, since we already started out with comparison ideas.
Yeah, the only problem is that project 2, you don't even know what it is yet, and you haven't learned the math yet. I mean, the statistics. So it's possible it worked, but there's a chance that it won't.
Okay.
Most people with project 2 don't do a survey.
Oh, okay.
They
It was-
compare. It's
I saw it.
comparison, but they usually do comparison by grabbing data from the internet.
I saw your notes to at least 2 groups saying, no, that's comparative. Look at, project 2. So I just thought I'd ask.
Yeah, so project 2 will happen, and it's possible that it could work for project 2, but it's also possible that it's not, and it's too early for me to explain it.
Sure.
Okay, so it's too early for me to explain it because it'd be over your heads because you haven't learned the material yet.
Of course.
So what I'm going to do is I'm just going to say, let's hold off on project 2, and let's just focus on project 1, which there should be one column in the spreadsheet with numbers in it, period. Okay, that's a mistake I see a lot of times. There's just one column, and use that one column, and that's it. Okay, and if you're doing stratified, you're not comparing the strata. You're just using the stratified to prevent some bias. Okay, that's just a note too. So even that doesn't have columns either. It all goes in one shot. Okay, yeah, one survey question. The only reason why you'd ask a second question is for the stratified, just to make sure you get your quotas. That's all, but not for the study itself. Okay, any other questions about the project? Okay, and I'll be checking, like I said, we're in weird times, which means I have like little plans. So all weekend I'll be checking too, because I think I'm gonna go hiking, but other than that, I'm around. Okay, so I'll be checking the internet a lot. Okay, a lot more than I want to. Okay, any questions on this? Okay, so now let's go to chapter 5. So I want to mention, somewhat similar to chapter 4, the original textbook's chapter 5 was much longer, and I got rid of half of it. So it's not really a whole chapter, it's really a section or 2. That's all we're doing, and that's why we can do it in one day. So we're doing basically 2 topics, okay? Whereas the original chapter 5 book had a bunch. And what I do is I go to conferences, statewide conferences, where there's 100 statistics professors at the conference. And then we could talk about what we're all teaching, and I try to do the same thing that everyone else is doing. So I try not to teach stuff that other people aren't teaching at the community college. And I try to make sure that everything is it. So just to let you know, if you're wondering, why did I cut half of chapter 5 out from the original chapter? That's the reason, because that's what everyone's doing, and I wanted to be. And the funny thing is now I'm like a leader, so now everyone's doing what I'm doing. They're all watching me, which is a little scary, actually. So that's what we're doing. And I want to talk about, we talked about last time, discrete distributions. And remember, discrete distributions is when you can count them out. You could list them. Okay, things like how many siblings are in your family, how many pairs of shoes do you own? There's a how many questions, and you could just list 1, 2, 3, 4, 5, or whatever. Like in the quiz on the expected value problem, there were only 3 different possible things that could happen. You remember that? And they were all numbers, and you could list them. Continuous distributions, you can't list. So things like how much do you weigh? You can't list all possible weights, okay? Because I weigh 168.352173 ... pounds. You see that? Goes on forever, Okay, you can't list it. It's a continuous distribution. And because of that, you cannot go and write a table. Okay, so if you can't write a table, but you want to display information, and we're going to do math. Any guess on what you can do? No guesses? Okay, what you can do is you can draw a graph. You can draw a continuous graph, a curve. And that's what I'm going to do. And what I'm going to have to do is I'm going to have to go to my drawing tool. I don't think I've used that yet in this class, but I can do it. And I want to give you kind of a general idea of what these look like. It's not exact anything, but that's okay. So the first thing is I'm going to draw a number line. And I'll just make it a line. And what we're going to have is we're going to have a distribution. Okay, so I am going to scribble. And the distribution might look something like that. Okay, and what we want to do is we want to talk about how does this show us probabilities? Because that's what we're interested in. We want to find out probability. Let's say, let me throw some numbers in. Let's suppose this was a, right there was a 2. And that was a 4. And that's a 6, etc. And we want to find out, well, what's the probability of something being between 2 and 4? And the way you define that is the following. You start at 2, and I'm going to draw a vertical line segment up to the graph. And then I'm going to go to 4, and I'm going to draw a vertical line segment up to the graph there. Any questions so far? Then what I'm going to do is I'm going to scribble. And I'm going to look at all of this stuff in here. In between 2 and 4 under this curve. Any questions so far? Let me save and close so we can now type right. So the probability of something occurring between, I was going to use A and B, in this case 2 and 4 is a picture, is the area below the curve above the x-axis and between A and B. Any questions on that idea? Any questions? Okay, now this is not necessarily easy to find. Okay, and in fact, give me a yes if you've had calculus, and a no if you have not. I know one person who has, but I don't know all of you, so maybe all of you have calculus, but I doubt it. Okay, pre-calc doesn't count, by the way. So my guess is almost everyone's going to be no, but we'll see. Okay. Yeah, 104 is not calculus, by the way. That doesn't count. Okay. Okay, so most of you are saying no. Okay, so let me just tell you something. The only way to really find this area in a curve like this is to use calculus. And we are not going to do calculus or learn calculus in this class. So there are two possibilities that can happen. One possibility is we use technology and we just say, do it. And then trust the computer to do it right. Okay, even though you have no idea what it's doing. And we're going to do a lot of that in this class, just not today. The other thing that could happen is we could get lucky. We could get lucky. And when I say we could get lucky, what I mean is it could be, instead of this strange curve that I drew, it could be a nice curve that you know how to find the area of. What's the nicest thing that you know how to find the area of? This you should all know. You don't have to have had calculus or even pre-calc for this.
Square.
Yeah, rectangle. A square too, but rectangle is what we're going to be looking at. Okay, so a rectangle is going to be the nicest thing that we know how to find the area of. And hopefully everyone knows how to find the area of a rectangle. Base times height. Do y'all remember that? Okay, so in this chapter, we're going to be using that base times height a lot. After this chapter, we're going to leave the rectangle and we're going to go to kind of sloppy figures like this, where you're going to have no idea what's going on and you're just going to trust technology. Does that make sense? So in a way, one of the points of this chapter is to get a good feel of what's happening so that you can actually do it. Whereas when you trust technology, you'll have an idea of what's happening, you just won't know the math. Sound good? And from now on out, I'm going to be saying that a lot. You don't know the math. And this is where you got to trust me as the instructor, is that I do know the math and it's brutal. And I'll tell you that too. Okay. But one more thing I want to mention about the area. What is the total area from the very farthest left to the very farthest right? What must that area be? And that you should all know. Yeah, the area has to be 1, because that's the probability that something happens. And there's always a probability of 1. If you look at all the possibilities, there's a 100% chance that one of those possibilities happened. Be kind of like saying, well, if I looked at, the probability, if I looked at the probability that someone is a certain age who got the coronavirus, since that's a big thing in the news, then what's the probability that someone who gets the coronavirus is between negative infinity and infinity years old?
100%.
Yeah, 100%, of course. Okay, because you can't be under negative infinity, you can't be over infinity years old. Does that make sense? So that's why the probability of the entire region is always 1. We're going to be using that a lot today. So that's just a big note. Any questions on that? Okay, so now I'm going to give you an example, and the rest of this talk is going to be examples where we know how to do the math. Okay. So here's an example. Suppose that the time that students spend in the Math Center, okay, and maybe nowadays the Math Center is Cranium Cafe, by the way, is uniformly distributed between 10 and 120 minutes, okay? By the way, when I say suppose, I just made it up, just go with it. Okay, so the first thing, you've seen the word uniformly, and just in English. What's uniformly mean?
The
And
same.
we've talked about this, yeah, all the same. What that means is that the probability of any interval of the same length or the same width will be the same as any other interval of that same width. Okay, as long as you're between 10 and 120. Any questions on that first? Okay, so part A, if a randomly selected MATLAB user is observed, find the probability that the student will spend between 30 and 70 minutes in the lab. What I need to do is I'm going to draw a picture. Let me put it all on the page. And I'm going to draw a picture. So now we're in between 10 and 120. Okay, so let me go and insert the picture. So I'm going to do what I did before. Good old x-axis. And then I'm going to put in 10 and 120. somewhere like that. And then what I'm going to do is the following. I'm going to put in a shape. In particular, I'm going to put in a rectangle. And for this rectangle, it's going to start at 10, and it's going to end at 120. This is not perfectly drawn to scale, but it's good enough for me. Any questions on that? So because it's uniformly distributed, we know that we must have a flat top. You can't get a higher probability on one side than the other. It just stays the same. So whenever you have a uniform distribution, you get a rectangle. And as you said, rectangles are the one thing we know how to find areas of. That's a good thing. Any questions so far? I'm going to do one more thing. I'm going to label H for the height of the rectangle, which we don't know right away, but we'll be able to figure out. And I'm going to save this guy. Any questions on my picture so far? Okay, now it's time to find H. How do I find H? Any thoughts? How do I find the height of this rectangle? Yeah, it looks like you got it. I'm going to show more work than you got, but definitely you got it. So H, so what we're going to do is we're going to say the area of the rectangle has to be 1 because everything is in this rectangle. It can't be anything below 10 or above 120. It can't be anything above H, okay, or the probability just sits at H. So that means the area of the rectangle is 1. So what I'm going to do is I'm going to say the area is equal to, I'm just going to write BH, base times height. And now what I'm going to do is going to say, well, how do I get the base? Well, if we're going from 10 to 120, I subtract. 120 minus 10 is the base, times the height, which is H. That must equal 1. Any questions so far? Okay, then we could do a little quick. You could use a calculator, or you can do it in your head. 120 minus 10 is 110. So now we can say 110 times H is equal to 1. I do want to give you a small warning about today, whether you like it or not. Today is one of the days where we actually do algebra. Okay, but the good news is nothing intense. There's no logarithms or exponents or things like that. Very basic algebra, we got to do algebra. So if you have 110 times H equals 1, how do I get H by itself? Algebra-wise. So we have an algebra problem. How do I get H? Yeah, I divide by 110. So what that means is that H is now equal to 1 over 110. Any questions at all on kind of the starting up? No, they haven't even gotten to part A yet. Right now, I just need to draw my picture from what's given. Okay, so now what we've got is a randomly selected math lab user is observed. Find the probability that the student will spend between 30 and 70 minutes in the math lab. So now what I'm going to do, I'm going to copy it. And hopefully it'll let me edit. There it is. Now I'm going to edit it. Okay. And remember, I want to go between, I already lost it. Sorry. One more time. 30 and 70. Let me write it down. 30 to 70 minutes. So I'm going to draw that picture. And we want to find that probability. So I'm going to edit it. I'm going to put another rectangle in. Grab a rectangle. And I'm going to go 30 to 70. 30's around here. 70's around here. And let's make it yellow inside. And let's whoops, put in some numbers, 30, 70. And let's get that 120 back in the nice spot. Okay, so there's our picture. There's our picture for part A. Okay, if you can do the picture, this is actually not that hard. If you can't, then it gets tough. So now we want the probability that it's between 30 and 70. Do you remember the definition of probability that we had at the beginning of this little talk? How do I find a probability? The hint is look yellow. So probability that 30 is less than X, which is less than 70, is equal to, so if you remember, probability by definition is the area. Well, we have another rectangle. That yellow is a rectangle, isn't it? So that's going to be the base times the height. What's the base? Okay, if you take the base, look at that yellow rectangle, means how far do you have to go? Yeah, you go from 30 to 70, 70 minus 30. I know some of you can do it in your head, but I think it's better for teaching purposes to kind of show you what's going on. And then times the height, well, we already found the height. That was 1 over 110. So we needed that height. And that is equal to 70 minus 30 is 40. 40 out of 110 is 4/11. Okay, and just a note, if you're doing this for your computer homework, you'll probably have to make that a decimal using a calculator. Any questions on part A? Any questions on how to do this? Okay, let's look at part B. Find the first quartile for the time that students spend in the math lab. So now what I'm going to do is I'm going to go back to my original picture and copy it, put it in there. I'm going to draw a picture. So we want to find the first quartile. Who remembers what first quartile means? Yeah, it means 25% chance. The probability is 25% to get below that number. Okay, we don't know what that number is, but what we can do, just kind of in general, we can draw around 1/4 or so. And again, we don't know that number, but I can, let's call it X. If you don't know something in math, you often just call it X, right? What do I know? 25%. What is 25% in the picture? What does that represent for the picture? Yeah, it's yellow, but it's actually the area of the yellow rectangle. So I am going to put 0.25 in the rectangle to show that that's an area. It's not a value of X. Is that clear? It's an area. So you don't put the 0.25 on the X-axis. You put the 0.25 to show the area. Okay, any questions on that? Okay, now we're ready to answer the question, doing a little math. There's always a little math to do. So now what we know is our area is 0.25. There's our area. So I can write 0 to 0.25. It's a little easier to read that way. Well, area is the base times the height. The base is, well, you look at that yellow rectangle, that's how wide the bottom is. And you always subtract the right minus left to get that base. And that's x minus 10. As Austin mentioned. What's the height? Any guess? Anybody knows? The hint is it's easy. Yeah, it's 1 over 110. That doesn't change. It's the same height. 1 over 110. All right, and then you don't have to do this, but I think it'll be easier mathematically to rewrite equals 0.25. Okay, so now we need x. We're not looking for a probability, we're looking for a value of x. We have an equation, and we want to get x by itself. So guess what? Algebra. Okay, so we got to do some algebra. So let's see if, what's the first step in the algebra to get x by itself? Okay, some thoughts, but I was hoping not just a number. Okay, the first step is to multiply by 110. Because we have x minus 10 times 1 over 110 equals 0.25. If we multiply by 110 on both sides, then that will get rid of the 1 over 110. And I think I'll do that in red, so you can see that that was what was done. Any questions so far? Any questions? Okay, now when you multiply by 110, the whole point is to get rid of the 1 over 110. So what we have now is that x minus 10 is equal to 0.25 times 110. And you all know how to do that, right? That's what, 27.5. Takes me a moment to do it in my head, but you can use a calculator if you want. And then what's the final thing to get the x by itself? What do we have to do? Yeah, we add 10. We add 10 to both sides because you have a minus 10. So if we add 10 to both sides, we get x is equal to 37.5. And there's the answer. That's the first quartile. Any questions on that? Okay, so now what I want to do, and let's see. Pretty many. I think I'm going to have you work on this. So what I want you to do is I want you to work on this part C. The hint is part C is pretty similar to part B. It's not exactly the same, but it's pretty similar. So that's a big hint. Let me read it. An algebra instructor will be giving extra credit to the students in the top 8% based on how long they spend in the math lab. At least how long must a student spend in the math lab to get the extra credit? I want to give you a minute or two to see if you can work this out. And you probably want paper and pencil so you can draw your rectangle and work it out. And the hint is it's not that different from part B, but there is a difference other than just the number. So I'm going to give you a minute or two. Maybe I'll be a little quiet, drink some water, and see if you can work this out. And if you're stuck and you need help, pop in the chat box where you're stuck, and Either Anna or I will get you unstuck. Let's give it a minute or two and then we'll all do it together in terms of the answer. It should take most of you take a minute or two. So I want to give it a little bit more time. I'm gonna wait till 2:35 on my clock. I got 2:34 right now. I got really worried this morning because our internet died for about 10 minutes. I'm like, oh no. And they came back. Okay, I got 2:35. Well, I'm gonna count to 3. You could, what you want to do is type in the chat box, and then when I say 3, hit enter. So give a moment to type. One, 2, 3, hit enter. Okay, it's a good sign that I see the same thing through a bunch of times. So 111.2. Okay, good. It looks like you're getting it. Okay, at least those who put in the chat box. Okay, and by the way, one of the things that you always want to do is you want to look at the answer and see, is it reasonable? And if you look at 111.2, is that kind of a lot? Is that high on the numbers? Because we want top 8% should be a high number, right? And is 111.2 pretty high when your range is from 10 to 120? Yeah, I mean, if you look at it, it's on the high side. Does that make sense? If you had a number like 22, you should worry a lot because that's on the low side. And top 8% is high side. Okay, so the way you do this, I think I'm gonna just talk it out quickly because it looks like most of you got it. And that is, you draw basically a same picture, except that the yellow will be on the right instead of left. And instead of a x minus 10, you'll have 120 minus x times the 1 over 110 equals 0.08. And then you solve for x and you get 111.2. Is there anyone that needs a full explanation of this? Okay, all right, then I think we're gonna move on. I don't think I need to do all of these. I just, there's a worksheet I've got. Maybe I'll do some. You could use complements too. It's a little more work to use complements, but that'll work too. Okay. I want to do a couple of these at the end. I'm going to skip a bit because we only have so much time to do so much. Okay. How about F? So let's look at F. So what is the probability that a student spends exactly 25 minutes in the math lab? It's an interesting question, isn't it? By the way, could it happen that a student spends exactly 25 minutes in the math lab? Given our picture over here? Could it happen a student spends exactly 25 minutes? Sure. Sure. Okay. Based on this picture, it can't be that they spend 150 minutes or 3 minutes, but 25 minutes can happen. Okay, now I'm going to give you some, now we're going to do the answer and it's just going to feel wrong. I want to give you a warning on that. So I'm going to copy this guy. So we want, again, in F, the probability the student spends exactly 25 minutes in the lab. All right. So we want a probability. So that's like the first one we did. That was like part A. But what am I drawing this time? To be exactly 25 minutes. What's the range if it's exactly 25 minutes? It goes from what to what? Actually not 1/10 of a 1 over 110th of a line. Because if they did 100 and if they did so again we want exactly again 25 minutes. And let's go back. If they did 24.999 minutes, is that exactly 25 minutes? No. Yeah, the range is 25 to 25. So here's the weird thing. And I'm going to put 25 here. Oops. There's our picture. What's the area? What's the area of the region between 25 and 25 of height 1 over 110? Yeah, it's 0. Because the width of the rectangle from 25 to 25 is just 0. 25 minus 25 is 0. So the probability is 0 of exactly 25 is 0. It feels weird because we saw it could happen, but the probability is 0. So you got to be a little careful. Okay, this is where things get weird. Intuition does not always match the mathematics. That's a big warning. Okay, probability of exactly any number will always be 0 with a continuous variable. Any questions on that? Okay, let's look at G. So I'll do these last two. What is the probability that at least 20 of 30 randomly selected students will spend less than 40 minutes in the math lab each? How do I do this one? Any suggestions on what this is gonna, what the strategy is for this? Any suggestions? Gonna give y'all a moment or two. Any suggestions on the strategy for this one? So part G. So what's the probability that at least 30 randomly selected students, 20 of 30 randomly selected students will spend less than 40 minutes in math lab each? Any thoughts? Okay, so it turns out this one is a combination of chapter 4 and 5. That's why I wanted to make sure we do this one, because this is chapter 4 and 5. Because what we've got is we've got 30 trials, 30 people. And each person is either going to spend less than 40 minutes or not spend less than 40 minutes. And we want to find out how many of them spent less than 40. That's binomial. Any questions on that? So that's the first thing. I'm just going to write that down. So now let's get Now let's get the pieces that we need out of this. Okay, so we got a binomial distribution. All right, how many trials? How many trials are there for this binomial distribution? This is not a trick question. It's not supposed to be too hard if you read the question, if you read part G. How many trials are there? Yeah, there's 30. We got 30 people, and that's our N, okay, our number of trials. What's the range? So it goes from something to something. What's the range? Okay. All right, let's think about it. What's the probability that at least 20? Remember, you have to be at least 21 to buy alcohol, remember? Yeah, 20 to 30. Does that make sense? So it's 20 to 30 because at least is greater than or equal to. So the range is going to be 20, comma 30. Okay, what's left to do? What do we still need to be able to go to our computer and work this out? Yeah, we need P. How do we get P? How do we get the probability that someone spends less than 40 minutes in the math lab? Yeah, now we're back to our chapter again. So for our P, what we need to do is we need to draw a rectangle again. And we want less than 40. So I'm going to put a rectangle in. And less than 40. Something like that. Let's make it yellow. And there's our picture. Any questions so far? Okay, so let's find P. Well, P is the area, and that's the base times the height. Let me write B times H, base times height. Our base is 40 minus 10. And our height is 1 over 110. That hasn't changed in this whole example. Okay. Which, by the way, 40 minus 10 is 30. 30 times 1 over 110 is 3/11. Okay, and we're going to need a decimal because it's the computer that we're going to pop this into. What is 3/11 as a decimal? And you should all know how to use your computer to get that answer. So it's 3/11 to maybe 4 decimal places. Let's see, I'll jump in at once. There we go, 2727. Okay, so now what we need to do is go to that program, and I'm just going to use the quiz because it's up there already. If I remember right, I think that was question 1. And I'll just pop them in. Our low was 20. Our high was 30. Our number of trials was 30. And P was 0.2727. And hit calculate. 20 to 30. And so it's a very low probability is what it says. Number of trials, probability of success is 0.2727. Let me double check that. That doesn't feel right. That's why. Yeah. So if you use a stronger computer, you get something so close to 0 that it's got an E -6 in it. Okay. So it's basically 0. To 4 decimal places, it's 0. Okay. Doesn't mean it can't happen, but it's very rare. Any questions at all on this example? Okay, so the last thing I want to do is I want to talk about some statistics. Let me pop in the picture again. That picture is nice to have, and copy and paste works beautiful. And I'm going to change the picture a bit. And let's just say this is A and this is B. Now we're going back to general. Okay, the first thing I want to mention, because I haven't done this and we need to do it, is a notation to talk about a uniform distribution. And what we say is X, and then that's called a tilde. Those who speak Spanish, that's what goes on top of an ñ. Okay, if you don't speak Spanish, it is what it is. So it's X tilde U A B, A comma B, where A is the left and B is the right for a uniform distribution. That's how you draw the distribution. That's how you, notate the distribution is probably a better word. Okay, so what do you think the mean is, or the also called the expected value? How do you get the mean of the uniform distribution? The hint is look at the picture. It might be obvious. Yeah. So notice that the mean should be right in the middle. This is a symmetric distribution. When you have a symmetric distribution, the mean is the same as the median. The median, you just add A and B and divide by 2. It's the average. I'm going to write that out. And what I can say, remember mu is the letter we use for mean, is equal to, and we're going to have a fraction. On the top is A plus B, and the bottom is 2. And that is way too small. Okay, so that's the mean. Okay, the mean is, I don't know about obvious, but it's intuitive if you think about it for a bit. Okay, now I'm going to tell you the standard deviation. And I'm also going to tell you, don't try to understand why, okay? Unless you want to be a math major. It's going to be one of these trust me's. Okay, so what I hope is you remember the symbol for standard deviation, and that is that sigma. So sigma is the square root of the fraction of B minus A squared over 12. And what I'm going to tell you is believe it, okay? The reason is very difficult, and I'm not going there, okay? It involves advanced calculus, and I can't do that for you. But it's a formula that's important. You don't have to memorize it, but you should have it written down. What I think I'm going to do is allow you a note sheet. You just got to show the note sheet to Factorio, and then that should be on your note sheet. You should have the formulas you need on the note sheet. There were a bunch of formulas in chapter 3 you definitely want on the note sheet. Okay? The formulas the calculator doesn't do for you. Any questions so far? All right, so now let's do a problem. So suppose that the number of ounces of water that people drink from the drinking fountain is uniformly distributed between 1 and 8, and that the number of ounces of water that students use to fill their bottles in the drinking fountain. So I don't know if you've all been to LTCC, but when you go to the drinking fountain, you have two choices. You can just take a drink, or you can stick your water bottle and let it pour. Okay, and the number of ounces that students use to fill their bottles in the drinking fountain is uniformly distributed between 4 and 16 ounces. You watch Thorn take 2.5 ounce drink out of the drinking fountain. Okay, and Preston fill his water bottle with 5 ounces of water before he runs off to class. Okay, whose water usage is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? Any questions on the question? Okay, so now what I want to ask y'all is, and we've had this, how do we measure how unusual a value is? And the hint is that was in chapter 2. Yeah, the z-score. So we need the z-score. So let me remind you first that z was equal to a fraction, x minus mu divided by sigma. And for some reason, it always makes it really small when I do these things. So let's make it bigger. Oops, that should be sigma, not theta. There we go. Any questions so far? All right, so we need to find mu and sigma. And we want to compare, okay, we want to compare Thorn and Preston. Any questions on the idea? All right, so what we're going to do is we need to find mu and sigma for Thorn. We need to find mu and sigma, and x actually too, for Preston. So what I'm going to do is let's start with Thorn. I don't need that so big. So let's start with Thorn. So the first thing is let's look at Thorn's distribution. So Thorn, okay, took a 2.5 ounce drink out of the drinking fountain. Thorn's just drinking, okay, not filling a bottle. So what is the distribution for Thorn? For Thorn's peers is what I should say. So the first thing is let's write x tilde u, it's uniform because it says, and it's between what and what? Yeah, 1 and 8. So 1 comma 8. So it's nice to have this notation because it tells you everything you need to know to do these kind of problems. Any questions so far? Okay, so now that we know that x is uniform between 1 and 8, we can now find mu and sigma. So let's start with mu. How do we get mu? So the answer shouldn't be so hard. How do we get mu for Thorn's mu? Don't see y'all jumping in, but it shouldn't be too bad. The hint is there's a formula. You might be looking at it. Yeah, yeah, I'm gonna put some parentheses around that or notice in a fraction. 1 plus 8 over 2. And I want to give you a warning about this. This is a calculator warning. In the calculator, if you put 1 plus 8 divide by 2 and hit enter, okay, or a computer or whatever, it won't give you the right answer. How come? Okay, the reason is we need parentheses. It's 1 plus 8 in parentheses divided by 2. So that's what you do in your calculator, your computer calculator. Is you got to have the parentheses or it'll be wrong. Okay, and that's 9/2. Any questions on that? Or 4.5? Any questions on finding mu for Thorne? Okay, now let's find sigma. Sigma is messier. I don't know if it's harder, but it's definitely messier. So for sigma, that was equal to, well, there's a formula, square root of b minus a squared over 12. Okay, b is 8. I need parentheses. 8 minus a was 1. Want to square that guy. And then we're dividing by 12.
Larry, scroll down a little bit. Just I'm having
I hear someone kind of talking, but it's staticky, so I can't hear your question. Not even sure who it is, but if you have a question, be happy to answer. No? Okay. Oh, your mic is weird. Yeah, you could always put in the chat box too if the mic's not working. Okay. So now what I want you to do, because I'm sure, I shouldn't say that because I can do it, but my guess, you can't see. Okay, how's that? Sometimes what I'm looking at is not the same thing as what you're looking at. Okay, my guess is that most of you, probably maybe all of you, but definitely most of you, can't do that in your head. The square root of 8 minus 1 squared over 12. So let's see if you can pop it in a calculator and tell me what you get. I could do about 1 digit, 1 decimal, but I can't do more than 1 decimal in my head. So at least check your work a little bit. And let's see if you can put that in your calculator. And again, or your computer calculator is fine. And make sure you can get this. And then I always have fun. I try and do it in my head and see if I can get what you get. You're better than I am because you're using machine. Where I'm trying to do this in my head, but I got a good idea. Oops. One more space equal. Let's see what you get. But it's very important you know how to do this. Good, good. In my head, I could do 2.0. There's no way I could do 2.020725. But let's call that 2.02 is good enough. Okay. Any questions? Any questions on that? By the way, what is x? X is the easiest of all because it's just given. What's x? You have to read the paragraph. It's the only visible number. So what's x in this case? Yeah, 2.5, because it says Thorn took out a 2.5 ounce drink out of the drinking fountain. So 2.5. Any questions on this? So now we're ready to get Thorn's z-score. So now what we can say is that Thorn's z is equal to, we can make a fraction out of it, well, it's supposed to be x, which is 2.5, minus mu, which was 4.5, divided by sigma, which was 2.02. Make that a little bigger. And again, put that in your calculator. And tell me what you get. This one I can do in my head pretty well on this one. What do you get? What's 2.5 minus 4.5 over 2.02? Yeah, negative 0.99. Okay, any questions on that? Okay, so now what I'm going to do, I'm going to save some time. I'm just copy and paste this guy. So we got to do the same thing, but now we're going to do it for Preston. So let's just change what we need to change. Let's go for Preston now. And let's figure out what Preston's distribution is. So for Preston, it's uniform between what and what? Not 1 and 8 anymore. So Preston, by the way, is drinking out of a water bottle and filling his bottle. So what's Preston's uniform distribution between what and what? And the hint is it's in there. Yeah, 4 to 16. So I'm going to take that 1, make it a 4. I'm going to take that 8, make it a 16. Okay, and then I can take the mu, and instead of 1 plus 8 over 2, now it's going to be 4 plus 16 over 2. Oops. And 4 plus 16 over 2 is 20 over 2, which is 10. Any questions so far? Okay, now let's get Preston's sigma. So instead of 8 minus 1, it's 16 minus 4. So it'll be the square root of 16 minus 4 squared over 12. That will not be 2.02. What will that be? What do you get? And if you want to save some time, it's just the square root of 12. Which is a little more, which is in between 3 and 4. So it's probably 3.7-ish. But I'm going to let you tell me what it is. because it is really important that you practice doing calculations like this, because there's a lot of that in this class. 3.46, that's a little off, but not too bad. 3.464, so 46. We'll go 2 decimals because that's what I did for the last one. Okay, and then Preston's X value is what? That's given in the problem. Not quite as easily seen as Thorne's, because Thorne just look for the number. Here you have to read a word. And what's Preston's X value? Yeah, 5. Because it says Preston fills his water bottle with 5 ounces of water before he runs into class. So now we just put everything in. So our Z is going to be X, which is 5, minus the mean, which was 10, over the standard deviation, which is 3.46. And tell me what you get. We're good. Good. I got my head around 1.5, 1.44 is good enough. Negative 1.44. So now we look at that and we can answer the question. So whose water usage is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? So how do you answer this question? The answer is it Thorne or Preston? Yeah, Preston, because notice Preston's Z-score is smaller, right? On the farther away from 0 to the left than Thorne's Z-score. So we could say Preston's water usage was more unusually small compared to typical use of that type. Okay. Any questions on this? Any questions? So I want to mention when we're doing uniform distribution, there's really 2 types of problems. Just like on Tuesday, we had 2 types of problems. We had the expected values and standard deviation problems, and then we had the binomial problems. Here we also have 2 kinds of problems. So let me scroll. One kind of problem is when you have to draw a picture and then work out areas and solve based on areas for a picture. And that's when either you want to find a probability, or if you're given a probability and you want to find X. Okay. Then the other kind of problem is when you're more interested in the mean and standard deviation of the distribution. And that uses this formula, mu equals a plus b over 2, and sigma equals the square root of b minus a squared over 12. Okay. So those are the 2 kinds of problems in this chapter. Again, the chapter doesn't have that much stuff, but you need to get good at those 2 kinds of problems. By the way, do you think this stuff is going to be on the test next week? Yes. Yes. So what's the best way to prepare for the test, since we got a weekend coming? Yeah, practice problems. Okay, practice problems. Okay, and by the way, the homework has lots of practice problems. And even if you get it right, you could do it again. And then you'll get a different problem and try that one. And don't be worried if you get it right and get, say, 100% on that problem, and you get it wrong the next time, you still get your 100%. You don't lose points if you try again, even if you get it wrong the second time. So what I recommend is practice on, working this out. Okay, that's the most important thing. You want to practice these two types of uniform problems. You want to practice the binomial problem. You want to practice the expected value problems. And then, of course, you want to practice chapter 3 problems. Those are the hardest. And chapters 1 and 2, that is a little different than regular practicing. There's not a lot of calculations kind of stuff. It's not your typical math kind of problems. Those you want to practice having conversations about. So your project should help you a lot with chapters 1 and 2. Because really that's what chapters 1 and 2, the project is about, chapters 1 and 2. So kind of your best bet on, or one of your best bets for getting ready for 1 and 2 is really doing your project right, truly understanding it. Okay, there's some things that aren't on your project like proportions, but a lot of chapter 1 and 2 is in your project. And again, you're only doing one sampling method, and you have to know how to do what all the different sampling methods are like that we've talked about. Okay, so I want to mention something in the calendar since we still have a little bit of time left. You don't have to go to the end, but I do want to mention the calendar, and that is important. Because there's some big stuff coming up, and that's why I want to remind you. So the first biggie is April 28th. So April 28th, your project must be done. Just to note, one of you, you only need to have one person submit the project. So only one person submits the project. The others will just take that, that project is theirs. When you do submit your project, make sure you have everyone's names on it. Otherwise, someone's going to get a 0 and they shouldn't, and then I got to deal with it, and that's not fun. Okay, so make sure that when you submit the project, that it has everyone, all 3 of you. If there's 3 of you that worked on it, your names need to be on it so that I can give credit. Because I only read the one person's submission, and the other I just give that number to, is how I do it. Okay, any questions on that? Okay, so that's important. That's how you submit. And again, I'm here to help you guys, and so is Anna, by the way, to help you with this project. And she'll look at I think, right, Anna, you'll look at their projects too?
Yes, I will.
Okay. I don't want to make any promises to someone else, but I know you. Okay, so both of us are happy to help you out. Okay, so I'll look at your project, give you suggestions. Anna will also, and Anna she knows what's going on. Okay, so work with us. I want you to do well, and this is especially the projects. They're a big part of the grade. 30% of your whole course grade are the 2 projects. So this is your chance to get help and do well in a non-stressful situation, whereas exams are a lot more stressful. Okay? So get the help. Don't wait till the last minute, because then you're not going to be able to get help. Okay. So that's just a big note. Then April 30th, which is a week from today, is your exam. There's a lot of big stuff coming next week. Next week is a huge in terms of points for the course. You got a project and you have your exam. Okay, and again, practice, practice, practice for the exam. The exam will cover everything we did up until today. On Tuesday, a big part of what we're going to do on Tuesday will be review for the exam. So that's just to let you know. I'm not giving a lecture on next Thursday, because you're taking your exam. So that's just a note. I kind of have the day off, except I got to grade your exam, so I don't really. But you're going to be doing the exam, and that's your focus on Thursday. Any questions? Any questions about anything? We're kind of running out of time. We have a little bit more, but we don't have to go to the end. Webinars are a little different, and we didn't take a break, so we're about right in terms of minutes.
I posted my project idea, my group project idea, and I did that Tuesday, and I don't see your response. Are we just good to go? Or?
Really?
Yeah.
Oh, no, let me look at it. Let's look at it now. You posted it to public, so there's nothing wrong with it. Are you okay with it being public?
Yeah, that's fine.
Because I just realized we are on Zoom. But that's minor. So I usually get back to everyone. There are a lot of posts, so it could be one I
We
missed.
did it at the end of ours. Is also it's at the bottom because you told me to start a new thread and I did.
Oh, maybe that was the problem, is that I couldn't find it. Let's see, who is it again? Who's talking? It's not showing me who's talking. What? Who are you?
Oh, Michael Drennan.
Okay, I just gotta find you. Oh, here you are, right here.
Yeah, it's so yeah, at the bottom of that one, and then there's also another one too.
Okay. Whatnot. Definitely should come up with an idea. Yeah, this one's not it.
That
I think I talked about that one.
oh, you did. Oh,
I think I did. I remember Chewy. But let me
okay.
look.
All right, I didn't see it. That's fine. That's weird. I didn't see
Are
it.
you looking now? Did you find it?
Yeah, yeah. All right.
Yeah, because I remember talking about Chewy. I wouldn't forget about Chewy. Yeah, so it's in there somewhere. So
Okay,
you got it? Does it make sense?
I'll
I
look.
can go find it. I don't remember exactly what I said because you can see I've done a lot of these guys. So tell me when to stop. I'm going pretty fast. Here you go. Yeah, so there's your Chew Ink. And what did I say? Here we go. Yeah, so remember there was it looked like you were together. See, Adria replied to you and then I had to reply to her, is the way it works. So
It's a different group, I think, but
is that a different group?
yeah,
You sure?
yeah.
Um,
I have Courtney and Austin.
Is that somewhere else?
Yeah, but I did see yours below mine. I'm gonna check that out.
It's probably somewhere else. Yeah, the problem is there are a lot of replies, so it gets like spaced around weird. Yeah, I must have said you're only supposed to ask one question, right? Because that's for sure. You only ask one question, not 3 questions. Or actually, I see 2. Yeah, I remember saying that. It's in there somewhere. That you're only supposed to ask one of the 2. And what is your monthly expenditure? I think is the one I suggested,
Okay.
or someone talked about it, because you want to tell them
Right.
how much they're going to spend on pet supplies monthly. So that company is going to be more interested in monthly expenditure than how many pets. Does that make sense?
Yep.
So
Alright,
that
yep.
came from your question.
Okay.
Okay, does that make sense?
One question. All right.
So that's the first thing, only one question. And in this case, monthly expenditure fits with how much would they spend monthly, right? Because you always want, you want to make your question relate to what you're interested in, obviously, right? Okay. And then in terms of sampling technique, again, with online, that's always challenging.
Okay.
So you're gonna, and you have some partners, I hope?
Yes.
Oh, good, that's necessary. So in terms of partners, you're gonna need to, you need to kind of split up the work. Online, you're gonna have to decide, you know, I think stratified is usually the easiest to do online because you don't have natural clusters online. That's the problem. Does that make sense?
Right. Okay. Stratified. All right. So stratified,
Yeah.
one question.
And you're gonna stratify by something, right? And I don't know if that already got approved.
No, you got confused because that's a new thread.
Okay, so it's a weird, yeah, threading kind of thing. So the idea is you're going to stratify. You're going to pick what you want to stratify that you think might matter when it comes to pet ownership, pet expenditures. Again, that
Maybe
could be
that's
by,
how we stratify.
yeah, it could be by gender, it could be by age, right? Those are things that might matter when it comes to how much people spend, right? And then you have to go and do research to find out. So if you did gender, for example, you have to find out what % are men and what % are women in your population. You have to decide what your population is too, right? You probably don't want the whole world to be your population, right? Because Chew Incorporate's probably not selling to Africa.
Right.
And money's a whole different thing. So you have to decide who it is. Okay, and by the way, this is for everybody, not just you, is that you have to decide who is your population of interest. Okay, it might be Californians, I don't know, and that's up to you. And then you do your research and say what percentage, if it was Californians, for example, what percentage of Californians, if you want to do it by, say, let's say you want to do it by gender, you'd say what percentage of Californians are men, what percent, or if you want to do it by race, you would say what percent are Caucasians, what percent are Hispanics, what percent are maybe other, because California is mostly Hispanic, Caucasian, and then there's groups of everything else, but those are the main two. Does that make sense?
Yeah.
And then take those percent, multiply by your sample size, which might be, say, 35 or something, or 31. And then those are your quotas. And that's how many people you have to get that have that specific race or that specific gender, depending what you stratify by. Does that make sense?
Yes, sir.
And that's how you're going to be doing this project. And you got to hurry on it because you got till Tuesday.
Yes.
Okay. So hopefully you have a lot of people you can email or Facebook or Snapchat or whatever you're using for your Zoom. Any other questions? Look in the box. I don't see anything new. I'm going to close the just a minute. I'm going to stop the recording because I'm done the thing I need to say.